welcome everyone. I'm speaking to you from Oklahoma City, yet another trade show, but looking forward to our conversation this morning. As Lance said, there are folks standing by to answer your questions. So if something comes up during my presentation that you'd like to either jot down for later, or you have a question immediately, then feel free to hop on that. So the topic today is broadband, which is obviously something most of us are familiar with, if not all of us. But the question I want to address this morning is, if I'm building a broadband network today, how long is that network going to be in, and what am I going to need to look for in the future? In other words, can I plan today for that application, that event that is going to take place in the future, that none of us know today what it might be specifically, but can we do a little thought experiment and figure out how to address that, so that we're not looking at having to upgrade or forklift our investment that we're making today in 5 years or so. So let's take a look in the crystal ball. As I'm sure all of you are aware, there is a huge investment these days in both the public and private sectors in rural broadband specifically. We did this about 10 years ago with broadband stimulus, but today the numbers that are being put out there in terms of funding really kind of dwarf that earlier effort. We are necessarily building to support our engagements today, the services that we have today, the customers that we have today. And if we're smart, we're putting a little extra in there for scalability for the future. But what about the types of services that are coming in the future? And how much do we need to scale? Those are the questions that we're going to address today. Then from an application standpoint, I think what we're seeing today, certainly what we're seeing today is, COVID was a great example of the ability of everyone to work from home. Not everyone, but a lot of people were able to work from home. You may recall early on in COVID, there were employers that were reluctant to let their employees work from home. They put they put cameras on their computers so they could keep an eye on them. That didn't last for long. Not only is it a terrible invasion of privacy, but they found out that people working from home are actually, in many cases, more productive than they are at the office. And so working from home is here to stay. I think in a lot of environments in a service-based economy, we certainly are going to see a lot more working from home. Cloud gaming, this is kind of a larger category that is more than just games, although that has certainly become a huge industry with billions of dollars associated with it. But also online environments, the metaverse, being able to shop in virtual reality, transact business, and so forth. So that virtual reality experience is really what cloud gaming represents here. Health and telemedicine. At my house during COVID, during the lockdowns, we had several doctor visits, but they were all done through telemedicine, through a broadband connection. Education as well is absolutely huge. Not only are we talking about primary and secondary kids being at home and having to zoom in to their lesson plan, but a large and growing percentage of post high school education is taking place remotely, where you can live in Arizona and get a degree from the University of Maine online. This is going to be a large percentage of education moving forward. And then finally, we are in the midst of a rural electrification project, very much like the one in the 1930s, except instead of electrical power, it's broadband, right? So I don't think there's any question that a broadband connection is a utility these days. It is just as important for quality of life as water and power and gas. As I mentioned before, these are just a few, but just a tremendous amount of public sector investment in rural broadband from both the federal level as well as multiple state initiatives out there. Now is the time. We have folks talking to us, customers talking to us, where they're paying, 25 cents on the dollar for fiber investment and so forth. So this is absolutely the time to make that investment. So if we're going to make the investment and the customers are there and the customers are going to be there, where do we make that investment? So traditionally, this is what we've seen in the broadband space, in the rural space. Your access rings, ubiquitous, low cost generally. Their job is to provide that media transfer or that media conversion from a PON, GPON, XGS-PON to Ethernet type environment. Because there are so many of them, these devices are necessarily lower cost. And because they're lower cost, they don't add a lot of services. General awareness of VLANs, general awareness of ERPS, 8032 protection rings, things like that, is really where they top out and where they should top out necessarily, because there are a lot of them and we got to keep the cost down. So what that means is in the service aggregation and the transport layer is really appropriately where the service awareness needs to take place. In other words, if we are looking beyond simply providing a big pipe to everyone, and we are detecting their traffic, understanding their traffic, and then providing appropriate service handling to enhance their experience, then that necessarily should take place and appropriately take place in the transport layer. On the right-hand side, of course, is the routers. Routers, of course, do what they do best, right? And that is supporting those diverse traffic needs to multiple endpoints, be they data centers, internet addresses, what have you. But in short, these are the resources that the end customers on the left-hand side of the screen are looking to access. They're looking to VPN to work. They're looking to book travel. They're streaming movies. They're shopping, internet commerce, and so forth. So this is the general map, the general outlay that you see, and in large part, this has not changed and should not change. It serves us very well, and it's a very mature and feature-rich architecture. So, in some cases, in the past at least, there has been a move to build a robust access layer and then stick a router on that ring. Now, in very low usage areas, in very small areas, this might be an appropriate solution. But for an enterprise that is geographically diverse, perhaps out in the West, in the big square states where you've got hours between locations, there is certainly a different architecture, a better architecture to support this. The problems, there are a number of problems with this in terms of its scalability and its appropriateness for growth moving forward. One is the lack of backbone scalability, right? If you have a 1 gig backbone, if you will, 1 gig connections or 10 gig connections, what happens when you get to one more gig, right? What happens when you get to one more gig than you currently have backbone room for? The scalability is an issue, and it requires going back in and forklifting chassis, or slotting new cards and buying all new optics and so forth. So over the long term, it becomes much more CapEx intensive. So with a transport backbone, we can let the access do what it does best, and that is do the media conversion, reach out one to many to multiple different types of services and end customers, and then aggregate all of that on a transport backbone. A transport backbone that we can scale from day one to 10 years later on a massive scale, moving from 10 gigabit to 100 gigabit to multiple terabits on a single fiber pair. Being able to transport at the optical layer gives us the absolute lowest latency possible. Depending on what services you need to support, this will allow additional revenue generating services. And this is a problem that I'm sure a lot of you are facing, where if you are up against competition in your geographic area and you can't buy them out, and your ads and drops or ads and losses in terms of customer accounts are roughly static, then how do you show increased revenue? How do you show revenue from a fixed geographical footprint? And so there's a couple of ways to do that, but the thing I'd like you to think about is putting a network in that will support premium services that allow your sales and marketing folks to offer a gold, silver, bronze type package. Maybe you already do that. Then think about platinum and titanium on top of that. And we're going to talk here in a few moments about those types of services and how we might want to handle those. And then finally, in the rural space, it's absolutely essential to be able to do more with less, right? At AT&T, they have 50 engineers to run a region. Rural providers don't have that, right? You've typically got 2 or 3 folks. You know, the bigger enterprises have half a dozen. But the key is to automate as much of this transport backbone, this service awareness and service handling, as is possible, and then give you a tool that gives you a simple and comprehensive way to view everything in your network and manage it appropriately, from configuration, performance management, all the way up to troubleshooting. So we're going to talk about priorities now. These are priorities in, if I'm going to build a network, then what do I need to be thinking about in terms of scoping that network out? Scale and distance. If you're building a network in Delaware, it's very different from building a network in Montana, right? In terms of the grouping of customers and the distances between locations, right? So scale and distance. How much traffic am I supporting today? How much traffic do I expect to be supporting in the future? And this is in terms of raw bandwidth, right? When you put a network in from Ribbon, we fully expect that it'll be there for 10 years. We have networks that are easily that old today in existing customer locations. We've even got devices that we sold 20 years ago that we're still supporting. So our solutions, our design philosophy is that you shouldn't have to forklift every few years to get that upgrade. So with that design philosophy in mind, when we're talking about scaling and what our network is going to be asked to do, we're thinking 5, 7, 8, 9, 10 years from now. And so that's why we're basically talking about this topic here. If your vendor is currently telling you, well, you know, yeah, this is going to be a great network for you, and then in 5 years we're going to sell you another one, well, then who cares what happens 7 years from now? You're going to build another network before then. Different way of going about it here at Ribbon. Traffic engineering. So traffic engineering is diversified services identification and then separate handling. So a good example of this is quality of service, right? We've had software differentiation of services for a while. You put priority tags on important traffic, and then it gets the HOV lane, right? In many cases, that's adequate. But what you'll see as we move forward into the future is that that will not continue to be adequate, that there will be services that need the very best that your network can offer, and quality of service is simply not going to cut it at that point. So traffic engineering, absolutely critical. I talked a moment ago about operational simplicity. As our service requirements get more complex, as networks get more complex and multi-layered, we have to do our best as vendors and as an industry to make it simpler, but yet just as powerful for you. And so that's absolutely critical from our point of view. And then really kind of the underpinning of this entire discussion is, how are we positioned for that next opportunity? Building a network for today's traffic is easy. Anybody can do it, right? The key here is what is coming down the pike that you need to be thinking about today. So if you invest today, now who knows if the government's going to come up with this much money 5 or 10 years from now. We have a window right now. We have opportunity. We have funding, and if you have a need to invest in a network today, then let's build for the long haul, and not simply for today and 18 months from now. Okay, so scale. Again, this is raw bandwidth, right? So, and this is pretty straightforward. I'm sure most of you consider this when even upgrading an existing network. But the key here, and the point I want to make here, is that a lot of times, a lot of focus is given to the access layer. So the PON devices, the XGS PON devices. And we're thinking, wow, that's going to be great, right? We're going to give XGS PON, we're going to put XGS PON out there. Well, keep in mind that the backbone must be sized appropriately so that you don't end up with too many drains on your bandwidth and not enough water pipe to feed them all, right? Because you will end up with customers that are getting starved of bandwidth. So balancing those customer requirements is something I know that you all do on a regular basis. This is really kind of at a macro scale, looking at if you're looking at a move to 10 gig PON or even more, then obviously the backbone needs to be sized appropriately to meet that requirement. Necessarily, this means that as you grow your access, as you grow your customer base, from a pure bandwidth standpoint, your backbone needs to scale easily and appropriately without forklifts and without a great deal of expense. Distance. Again, if you're building a network in, on the island of Manhattan, then this slide is not interesting to you, right? But America's a big place, and there are a lot of folks in the rural spaces that are quite a bit further away from the internet pops and so forth than folks in urban areas. And so, very simple explanation or example of how, with the technology that we have today, it's very easy to go 40 kilometers to 80 kilometers away from a particular location with pluggable gray wave optics. Okay, gray wave optics are your 1310 and 1550 optics. They are wideband. We call them wideband optics as well. And they're relatively inexpensive, particularly as compared to DWDM optics. However, DWDM optics, dense wave division multiplexing, multiple wavelengths on a single pair of fiber, those optics are a step above in terms of their precision and and in terms of what they're capable of doing. So DWDM optics, for instance, you can amplify them. So I can go further than 80 kilometers. In fact, I can go 200 kilometers, 240 kilometers, and perhaps even further, depending on what it is that we're trying to accomplish. With that amplification, I can also go today. I can do 200 gig, a 200 gig wavelength from Portland, Oregon to Portland, Maine, without having to do a hard regen, right? So without that regeneration, it keeps my costs low. I can go extremely long distances with very high bandwidth. So while the investment in DWDM optics is higher initially, the utility that DWDM has in terms of its scalability, how far it can go, how quickly it can scale, is really unsurpassed, right? And makes it kind of a no-brainer in terms of design considerations. So I love this slide because if I show this to folks from urban areas, they see a very different thing than folks from rural areas. So in the upper left, we have manufacturing. This might also be a data center. Why would I put this way out in the middle of the rural spaces? Well, simply put, because real estate's cheaper there. Power is cheaper there. This is a great place to put a data center. If you look at where data centers typically are, they are not in urban areas. They are in rural areas. Data centers make their money on high volume and then stability of services, stability of power, and then placing themselves in locations where there aren't earthquakes or fires or hurricanes or tornadoes. And so typically that is in rural, geographically, geologically stable areas. So this type of enterprise is going to be increasing in the future. It's already widespread. They don't advertise where they are because, again, they are a secure facility. But this is certainly going to be a big part of the rural space moving forward. Agriculture, well, the inside of that harvester, it looks like a data center itself, right? I mean, it is that there is so much technology in that device requiring broadband access. Education, it's a one-room schoolhouse. However, 6 computers at the back of the room in that one-room schoolhouse can open the world to those kids and give them the ability to have just as good an education as anybody in an urban area, perhaps even better when you consider quality of life. And then residential, that's a nice farmhouse. It's also a home business. It could be an extension of a data center. It's a home office. There could be a farmer in there running a multi-million-dollar operation. That's the headquarters of a CEO and a rural enterprise, right? So all of these are examples of the types of customers that we are looking to serve. And here behind the scenes, behind the pretty pictures, these are the types of services that they are demanding. Manufacturing, data centers and so forth, absolutely critical for reliability for business services, right? Reliability, I mentioned they are secure facilities, so they need security, they need isolation, digital isolation. And then there may be an opportunity for digital connectivity. Amazon warehouses going up everywhere. So many things there are done via barcode and robotics. That dynamic connectivity is absolutely critical in those environments. Agriculture, probably the largest user on the board here, right, in terms of what it's capable, the services that it is capable of requiring from us, right? The same as manufacturing. In fact, it is a manufacturing facility, right? They're manufacturing food and fiber. Education, critical to isolate and provide security for not only our school kids, but in terms of the resources that they access. Um, and then residential, in purely residential environments, there's shopping, there is streaming, there's the infotainment, right? Which of course is those are the hallmarks of residential broadband services. So I have all of these services, and each one of them is a little bit different. And so this slide is kind of an example of how to consider what types of services we're currently offering. And if we're not currently offering these services, it's a reminder that that if you only offer a single threaded service today, that if you go with the gold, silver, bronze type package, that's additional revenue that you could be recovering from your existing customer base, right? Again, the drive is always to increase revenue year over year over year. If you have a fixed customer base, how do you do that? You do that by offering better and more premium services. So internet-based entertainment, this is what we typically think of for broadband today, right? We watch movies, the kids play games, we get on, we do email, Facebook, whatever, Instagram. And generally a big pipe is fine for those folks, right? The access to services, the requirements for services, while it has ups and downs, it's generally not all at the same time. And so oversubscribing is the right way to go, because that's how you maximize your profit margin for a ubiquitous and commoditized service. Okay, we don't have to worry about latency so much. These are all best effort services. They've got buffering built into them, generally that will take care of any latency gaps and so forth. Premium gaming, or as I mentioned before, virtual reality solutions. Low latency is absolutely critical here, right? A premium service that offers low latency can also be extended into the business realm for either home day traders, high frequency traders, local brokerage offices, and so forth. Low latency is going to increasingly be more important as we move forward, and we're going to say more about this in a moment. This absolutely has to be handled appropriately, because there are low latency paths through your network, and there are not low latency paths through your network, and you want to make sure those customers are routed appropriately. This is not something where quality of service can help you. Distance learning, I mentioned that before. An increasing number of folks are going to be learning at home, and so a number of characteristics pop up here that need to be handled appropriately. Security, creating an environment where this restricted content, the content that is being paid for, needs to be locked down, and so unfettered access to paid content is clearly a problem. And then telehealth. Telehealth ultimately, and really a number of services out there. We really don't go very long before we hear a story of another municipality or another enterprise, another business that's been hacked. A database has been acquired of credit card numbers. I mean, you know what I'm talking about. This stuff happens all the time. There's no way to prevent it completely, but this is a consideration when building your enterprise in terms of building a defense in depth. Yes, VPN access for folks is widely available. You may not be offering that. It's just fine, but you can offer encryption. There are multiple layers, multiple offerings in terms of encryption that can be provided for services. Defense in depth is the concept that we talk about, where there is not just a wall, but there's a moat in front of the wall, and there's barbed wire on top of the wall, and on the inside we have a castle, and then there are locked gates and soldiers on the wall, and you get the idea, right? Defense in depth is a concept that we need to start thinking about. Legacy operations traditionally have been multi-screen. You look at your a screen for one part of the network and a screen for another part of the network, maybe your optical layer, and then a different one for your routers and a different one for your switches. That has to go away. Ultimately, that has to go away. It's inefficient, particularly when there's an issue, but not just when there's an issue, when you are configuring a service and you have to hit 3 different boxes to configure that service to make it operate properly. There are chances for errors. There are chances for not just providing not enough bandwidth or not the right handling, but too much, giving too much away. So automation is the way that management is going in terms of number one, being able to slim down the number of screens you're looking for to, 1, perhaps 2 at the most that you need to look at in terms of your enterprise operation. It needs to be graphics driven. It needs to be intuitive. It needs to give you graph and chart type interactivity so that specialized detailed knowledge of a command line is not required. It also needs to be multi-layer. It needs to show you optical. It needs to show you layer 2 Ethernet. It needs to show you layer 3 routing. And then the interplay between all of those. It also needs to give you automated templates so that once you have built a template for a service that you repeatedly sell, you can then again and again and again go back and apply that template and get that service turned up very, very rapidly. Ultimately, this comes down to a much more CapEx and OpEx cost effectiveness for your enterprise. This is a value-added tool that we believe should be ubiquitous. It already is ubiquitous in some cases. This is OTDR. You're all familiar with OTDR. OTDR gives you that trace that tells you exactly what's going on your fiber. The difference with this one is with Ribbon's OTDR solution, it gets installed on day 1, and then it runs inline and in service 24/7. And it keeps all of that data historically without service affecting, right? So this can run at any time, on any span, on every span in your network, and provide you that OTDR information. Absolutely critical to give you that much more peace of mind in terms of what's going on your outside plant. So the next opportunity, I use 5G here as an example because it is a quantum leap forward in terms of how we have to handle data. 4G today is simply big pipes. 5G will take 4G and make that one type of traffic that it handles. In addition to that, it creates an environment for a vast array of different service handlings, all at very high speed. So 5G is my example of the next app. And the reason why I can say that is because of what 5G is asking us. And we don't know what that new app is going to be. What we can say is that 7 years from now, there will be an app, and it will tax our networks if we haven't prepared for it. And that is going to require a fair amount of bandwidth. So we're going to need to scale for it because everybody's going to want that app. It's going to require low latency, or it will require latency support so that if it has low latency, if you've got autonomous cars that need a quick decision in terms of left, right, stop, back up, and so forth, that's a very low latency type of demand, right? Those types of commands, acknowledgements, and requests need to take place on a microsecond scale. So synchronization, precision of timing, and low latency will absolutely be required. And then finally, there will always be the best effort services. And of course, we will need to handle those appropriately. We will need to scale for the bandwidth for those. But detecting those diverse services on that app that's coming down the pipe, It's probably some type of virtual reality. It will require instant streaming. Um, that type of service is something that we can detect and build for today, so that when that app comes down the pike, you will have the tools in place to support it. So ultimately, what we are building here at Ribbon is a solution to support not just your solutions today and growth in the immediate future, but for the long term. We are putting tools in place today with our Neptune IP multi-service switches that are ready for 5G today in terms of Class C precision timing, in terms of hard slicing, segment routing, the ability to provide for those advanced applications that quite frankly aren't even here yet, but the boxes are ready today. Building all of that on a foundation of a massively scalable optical transport. The average solution that we put out there today is about 20 terabits in terms of its scalability. The great thing about that is you don't pay for 20 terabits today. It's a pay as you grow, right? If you need to turn up a single 100 gig backbone, that's easily done, and for the cost of a 100 gig backbone. When you need another one, when you need a 200, a 400, an 800, what have you, you can turn those up when you want to. Our development folks are looking at releasing a 1.2 terabit laser the beginning of next year. So this will be 1.2 terabit on a single wavelength, of which you can have dozens on a pair of fiber. And so the massively scalable backbone is available today as well. So the idea, in short, supporting today's services, tomorrow's services, when they come, are going to be supported by our devices today. In summary, we take a great deal of pride in being interoperable from a Ribbon's perspective. There will rarely be a case where we will be the only vendor in an enterprise. I'm sure that's true in your enterprises as well, right? You always are going to have to work and play well with others. And so we have built a number of tools in our solution that are designed specifically for interoperability, to be able to model other people's equipment. We are standards-based, absolutely standards-based. There's really no room for proprietary protocols and the like at Ribbon. We are widely deployed globally. Some of the biggest providers in the world, with hundreds of millions of end customers, are running today on Ribbon equipment. We are running 10 to 12 weeks in terms of delivery. So if you are running into a time crunch and you need to start lighting up the fiber that you're putting in the ground, give us a call. I'm sure we have a solution for you that can be delivered in a relatively short period of time. This is that we have had this delivery period for most of this year, quite frankly, and don't see it changing. So we've done a great deal of planning ahead to be able to achieve that. We are Buy America Act compliant with a great deal of RUS money out there today. There is a requirement to make sure that the equipment that you're putting in is compliant with the Buy America Act. That is something that Ribbon is very proud of being able to support. As I mentioned before, the pay-as-you-grow model, right? It is what the systems that we put in can be massively scalable for the future. But you don't pay for that scalability until you actually need it, right? So a very easy entry into a very scalable network. And then finally, we don't believe in persistent licensing fees, right? So from a software perspective, typically, and from a hardware perspective, once you buy it, it's yours, right? There are support contracts and maintenance contracts and so forth for additional tech support and hardware replacement and then the typical offerings there. but we will not be coming back to you year after year after year to continually license things that you've already purchased for us. That's a real differentiator for us. All right. So thank you so much for your time this morning. This is my contact information. I am the business unit leader for rural markets, specifically dedicated to rural markets. And your business is my business. I am absolutely excited to take your calls, to answer your questions. I am not a sales guy. I come from the engineering side. So if you just want to talk technology and ask some questions and kind of sort out where you need to move forward, give me a call, send me an email. If we need to get salespeople involved, of course, I'm happy to do that. But I'm really here for you, right? So give me a call and let's talk. Thanks for your time.